Here is a question on complex power. We have an electrical circuit with a sinusoidal voltage source and some impedances or loads are connected. The supply voltage is given 120 volt 30 degree and some information is given about this loads A, B and C. For example, load A consumes 4 kVA power at 0.8 leading power factor. Okay, so that means power consumed by load A is 4 into 0.8, 32 kilowatt. This is the real power, 3.2 kilowatt real power, plus the reactive component of power will be 4 multiplied by 0.6, okay, because if cos theta is 0.8 then sin theta is 0.6. So reactive component of the power will be 4 into 0.6, that means 2.4 kVAR, and since this is leading power factor, that means the sign should be here minus J. Okay, so this is the complex power consumed by load A. Similarly, let's consider load B. Okay, so load B is a 2.4 kVA load with power factor 0.6 lagging. So that means real power is 2.4 into 0.6, that will be equal to 1.44 kilowatt, and the reactive component will be 0.8 multiplied by 2.4, so that will be 1.92 J, and since the power factor is lagging, therefore the complex power consumed should have positive imaginary component. Now consider load C. Load C is an inductive load with active power 1 kilowatt. This is the power consumed, so active component of the power is 1 kilowatt and the reactive power is half kilowatt, and since this is inductive in nature, so we should have plus J 0.5 kilo. Okay, so all these units are kilo, and the dimension is volt ampere. That means watt for the real component and VAR for the imaginary component. Okay, so dimension wise this is equivalent to kilovolt ampere. Okay, now if we add all this together, we get total complex power consumed by all the three loads, and that will be 5.64 plus J 0.02 kilovolt ampere. That's the complex power consumed by all loads. So this is also equal to the complex power supplied by source. Okay, so therefore from here we can write that the source voltage, which is given here 120 volt 30 degree, okay, this multiplied by this current, if I call it I, so voltage multiplied by current conjugate, that should be equal to this total power supplied, complex power 5.64 plus J 0.02 kilo, so that means multiplied by 1000. Okay, so from here you will get the value of I star. If you divide, I star comes out to be 47 approximately, very close to 47 ampere with an angle of 29.8 minus 29.8 degree. Okay, and that means the current I that will be conjugate of this. Okay, that will be 47 ampere angle plus 29.8 degree. Okay, so the question asks to find out the RMS value of the current drawn from the voltage source, that means this current I, and that is 47 ampere approximately, and the phase of the current drawn from the voltage source, that will be 29.8 degree. So if you convert it into radian, you will get approximately 0.518 radian. That's the answer.